So we're going to do this worksheet together, and you guys are going to kind of do it on Jamboard. You can pop in and work together on each other's jams. You can help each other out. If someone looks like they know what they're doing, kind of scroll through all the different jams and see if someone kind of looks like they know what they're doing there. So I'm going to help you guys through this one. You guys can actually do this one kind of on your own. You guys know what you're doing here. So A says make a well-labeled diagram of the situation. A car accelerates from rest to a speed of 28 meters per second. And I'll just draw something. With some labels here, and we can kind of start our given section down here. And then guys, if you look on the jam board, I'll share it with you guys on the first page of the jam. That is where I have all of the formulas. Oh, no, I don't. Let me, 1 sec here, guys. They're on 2A's jam, so let me go grab them from there. So these are our 3 formulas here. If you guys look at page 1 of the jam board, share it up with you guys. These are our 3 formulas here. Either A equals VF minus VO divided by time, final velocity equals initial velocity plus acceleration times time, and then the big one, final position, XF equals initial position plus initial velocity times time plus 1/2 times acceleration times time squared. Now that formula can look a little scary, but a lot of the times, a lot of zeroing out goes on, a lot of canceling. 0 for initial position. That almost always happens, actually. 0 for initial position. Sometimes initial velocity is even 0, and then I'm just working with this teeny little bit of the equation. So it can seem like a doozy, but a lot of canceling out goes on there. Now, share back to my iPad with you guys. That first problem, I want you guys to draw the car accelerating on the graph, and I also want you to find the average acceleration of the car and to list how far it travels in this time. Now, what I'm going to do is I am going to, for 1 and 2, point you guys towards what formulas to use on my sheet. So for 1, I would use the acceleration equals final velocity minus initial velocity divided by time equation. And then for question 2 there, how far does it travel? I would use XF equals XO plus VOT plus 1/2 AT squared. So you guys go in and kind of solve number 1 here. It's time to do that. I'm going to watch along on the jam boards while you do that. You guys can watch each other and kind of work together and stuff like that. But that is what I want you guys to be doing. I only have, I don't have everybody in the jam board yet. If you guys are having trouble getting in, let me show you a new share. In Canvas, Monday Jamboard links, you click that, and then you click our class, and that should get you right to the jam. So get in that jam, guys, and create your own page, and go ahead and solve question 1 using the formulas that I showed you to use there. If you have questions, feel free to ask. And then in a couple minutes, I will solve the jam on my screen for anyone having any sort of trouble. Catherine, yes, you multiply velocity initial times the time for VOT. I don't realize that can be confusing over text. Hey, Nicole. So go ahead and open up the Jamboard in Canvas and go ahead and open up worksheet in Canvas under Monday worksheet or Monday review called Quantitative Acceleration Practice. See Nicole's in the jam. If you guys want to look at my jam, I'll start to solve this problem for you guys. Or my screen, sorry, not my jam. So final velocity of that car, 28 meters per second. Initial velocity, 0 meters per second. 20 seconds. Gives us 28 meters per second divided by 20 seconds. And I believe that is an acceleration of 1.4 meters per second squared. So as I'm looking around the Jamboard here, I see that most of you guys got 1.4 meters per second squared. And then for that bottom equation, that big doozy, I told you guys things were going to be canceling out, and they do. Initial position at the origin, that cancels out. Initial velocity is 0, so this whole thing, initial velocity and time, cancel out because we started at rest. So I just have xf equals 1/2 at squared left to deal with. I fill in the 1.4 meters per second squared that I just found, and my time of 20 seconds squared. Now 20 squared, do a little math, you have to square the 20 first. 20 squared equals 400 times 1.4 meters per second is 560. Divided by 1/2 equals, or times 1/2, sorry, equals 280 meters traveled. And then to finish this problem up graphically, the car accelerates from rest to a speed of 28 meters per second. It looks like a constant acceleration, so that line would just be a constant positively sloped line to show that constant acceleration. I'm going to give you guys a second to copy that stuff down, maybe screenshot it if you want to or need to, and then we will move on. Let's give you guys a couple minutes with this one. All right, guys, I'm going to scroll down to number 2 here. Sorry, my iPad's a little frozen.